Hello everyone, welcome back. We are approaching the last 2 or 3 videos for this particular chapter. Now, before I carry on, I'd just like to stress that in preparation for your examinations, right, this set of videos I think should be useful to most of you, but it should still be just a supplement, okay, an additional source of learning. You should still go through the notes in its totality, because ultimately whatever that comes from the notes should be tested in the exams, okay? So don't just bank everything on the videos and expect to do very well. This set of videos is meant to provide you with an understanding of how to approach your exam questions, and hopefully to make you understand what exactly is thermofluids. Alright, so previously we ended in the constant volume process, okay? The last two processes that we need to talk about are the polytropic and the adiabatic process. So polytropic and adiabatic are actually very similar. If you look at the formula table itself, alright, the equations, right, the formulas given are actually very similar, just that for polytropic you will see that the polytropic index n is being used, whereas for adiabatic the gamma, which is the adiabatic index, is being used. The form of the equations are all the same, okay, but I will still go through both of them. Now essentially this polytropic is kind of a generic expression for any kind of perfect gas process, okay? Apart from your characteristic equation where you have PV equals MRT, and you also have P1 V1 T1 equals P2 B2 T2. Apart from being able to apply this, you now have another equation which describes the process of which describes the shape of this process, which is P1 V1 to the power of n equals to P2 V2 to the power of n. Since these two are the same, they remain constant, okay, which you will often see in the question that PV to the power of n is constant. Okay, then straight away you will know that the question is trying to address a polytropic issue. Okay, so this is the additional one. Note that the power n is only applied to the volume. Okay, it is not applied to both P and V. Okay, it is only to the volume. And generally there are two kinds of tricky questions that you may encounter. The first one is that given P1 V1, okay, and given P2 V2, you're supposed to find n. Okay, so one of the type of question is this: find n with these four given. So what you should do is this is basically a mathematical problem, so you just shift all the terms with power n to one side. Okay, you should be able to get this. Okay, and you shift the non n power to the other side, which is the pressures. Okay, so you need, in order to solve for n, you need to bring it down, and in order to bring it down you need to log both sides. It can be power base 10 log Lg, or it can be natural log Ln, up to you. So if we do this, your n is now be able to come down here, okay, and your other side will be like this, okay, and your n, you will then be able to find it by bringing this term to the right hand side. B2. Okay, so this is how you find the polytropic index. Now the other kind of problem is if n is now given to you, okay, but now you are supposed to find, say, V1. How do you find your V1? Okay, or V2, up to you. So let's say now the unknown is V1, you need to find V1. You just shift P1 to the other side. You should be able to get this, right? So what you do is you need to get rid of the power n. Okay, in order to do this, you need to power both sides by the inverse of n. Okay, so I need to power both sides by the inverse of n. So this is what happens. Okay, because of this, your power will then cancel out and only V1 will remain. And the other side, you can actually write like this. Sorry, P2 over P1 to the power of 1 over n, and this one will actually cancel with this, and you become this. Okay, so this is how you find the volume. Yeah, like I said, you need to read through the notes to know more about what exactly is a polytropic process. And there are examples. What I've just gone through is also in the notes. Okay, how to do the mathematical manipulation to derive your answers, and the derivation of work done and heat transfer and change in internal energy are also here. So we go straight to example 4-6. Okay, so what you have is V1 is 1.12 meter cube. Okay, P1 is 80 pascals, which is 0.8 bar given here. Okay, and V1 is this V2. So V2 I have 0.5 meter cube, and P2 is 221000 pascals. Okay, so this question is to find n. So just now we managed to get this formulation. Okay, so it would just be P2 over P1 over V1 over V2. Let me see. Yeah, correct. Okay, so you just plug in your numbers. Okay, you see I always tend to write in SI units, but if you are looking at a ratio, right, a ratio of two pressures, you don't actually need to write in Pascal. You can express in bars because it's just a ratio between two pressures. Okay, so I can actually write this 2.21 divided by 0.8, because you know that this divided by this will be this divided by this. They are the same. Okay, log V1 over V2. And a final reminder, you need to practice pressing your calculator very often, or else you can commit mistakes very easily. Okay, and the answer is 1.26. Let me see. Yes, the answer is indeed 1.26, and this is the polytropic index.